Okay, this is section 3.2. And here we're going to talk about some things about fractions. We're going to talk about using prime factorization to reduce fractions. Okay, this may sound like a lot of work, but for big fractions or big numbers on your fractions is one of the best way to do it. So we're going to be practicing this a lot tomorrow, but right now we're going to just show you how to do it. So let's say I have two different numbers. Let's say I have, excuse me, 60, the fraction, well, let's just start with number 60, and I have the number 45. Okay, to do a prime factorization is to break it down into all prime numbers. So because it says prime, okay, we are factoring, you're gonna find all prime numbers. Remember, those are numbers that can only be multiplied or only be factored into themselves and 1. So prime numbers are like 2, because you can only do 2 times 1 to get it. 3, because there's no other number that divides evenly into 3 besides itself. 5, 7, okay, 11, etc. They go up higher, but these are pretty much the main first prime numbers. Now 1 is not considered prime. It is just the number 1. Sometimes people consider it prime, but we don't use it as a factor because 1 just multiplies or divides into all numbers. Okay, so what we're trying to do is find all prime numbers that are multiplied. That's what factorization means, to find all that are factors of a specific number. So that's what prime factorization really means. We're looking for all the prime numbers that are factors of a specific number. Now, factors is kind of a loose term, so I a lot of times like to say factors are really the numbers multiplied to give you that number. Okay, so that's what factors are. So you're looking for all the prime numbers that when multiplied together will equal the given number. So that's what we're looking for. So to do this process, I like to always start with the first prime number and check, does it go into my first one? And yes, it does. 2 goes into 60, so we can say 2 times 30, okay? And that's the easiest way to figure out, okay, I can divide 2 into it. So this stops because it's a prime number. So we're going to stop the branch right there, okay? Now I'm going to check 2 again. Does 2 go into 30? Yes, it does. 2 goes into 30 15 times. Again, that stops my prime, or that stops as a prime because 2 is prime, but 15 is not prime because it divides into 3 times 5. Well, we check, yes, 3 and 5 are both prime. So now I know my prime factorization of this is 2 times 2 times 3 times 5, which let's check. 4 times 3 times 5, 12 times 5. 12 times 5 is actually 60. Yes, when I multiply these together, it results in 60. So this is called the prime factorization of 60. It's the only numbers that are prime that you can multiply together to get 60. You can't use any other numbers. It's only those. So if I'm doing 45, if I look, 2 does not go into it, so I'm not going to use that one. But maybe 3 does. Or you can just say, what two numbers do I know multiply into 45? So I'm going to do that for right now because I know 5 times 9 is 45. Well, 5 is prime, so I can stop that one. 9 actually breaks into two numbers, which are 3 and 3, because 3 times 3 is 9. 9 times 5 is 45, so at each branch you can get the branch up above. Well, these are prime, so our prime factorization is 3 times 3 times 5. These three numbers were the prime numbers that each branch ended on. Again, you can check it. 3 times 3 is 9. 9 times 5 is 45. We know that gives us 45. So that's what it means to do a prime factorization. Now, let's say we had these as a or as a fraction. So if I had 45 over 60, what you can do is you can say, okay, 45 is 3 times 3 times 5, because that was our prime factorization. On the bottom, 60 is 2 times 2 times 3 times 5. Okay, if you look at these, a 5 divided by 5 is 1, so those cancel. A 3 divided by 3 is 1, so those cancel. What I'm left with is 3 over 4. I just reduced 45 over 60 down to 3 over 4. Now, it did require me to get the prime factorizations of each of these, but that's a really fast way. Instead of trying to figure out what numbers divide into both of these, this gives you what numbers divide into both of them, and so you can cancel those out and just have the remaining number. Okay? So that's something we're going to look at, is finding out if they are, how to reduce them. This is probably the most practical part of this section because I want you to know how to reduce fractions. You're going to need to know how to reduce fractions more and more and more as we go through algebra and advanced algebra, geometry, all of those things. You're going to have to do that. And in life, it's much easier to work with smaller numbers. That's why we reduce the fraction, because they're smaller numbers. And so it makes it easier to work with them than those larger numbers and trying to figure out what does that actually mean. So 3/4 is much easier to find or to know what that means than 45/60. That's a lot. Okay. So if we take, let's just try another one. Okay. Excuse me. Let's say that we are looking at reducing, I want to just see one here. Let's say we are looking at reducing, this is not too bad a one, so 55 over 165, okay? So again, we want to do the prime factorizations of both of these, okay? First thing I see in 55 is it can be divided by 5. That's 5 times 11. 11 is prime, so my prime factorization here is 5 times 11. Here I see 5 goes into this. If I take 5 into this, it gets me 33. Okay, if you want to double check that, 33 times 5. 5 times 3 is 15. 5 times 3 is 15 plus 1 is 165, so it does give me the same. I can break 33 down. It's 3 times 11. Again, now here are my prime factorizations. So 5 times 3 times 11, that's the factorization for 165. This is for 55. Now, once I have those, 55 over 165 is really the same as 5 times 11 over 5. I'm going to write times 11 times 3, because we can do that. We can switch multiplication order. It makes it kind of nice. So we get rid of the 5 and the 11. Oh, does that mean I have a 0 on top? No, I can't make it 0. We really have a 1 there that we have to remember. If it takes all of them out, we are still multiplying by 1. So this answer is actually 1/7. third. Hopefully much faster to reduce that way than trying to sit there and figure out what numbers can divide into both of these equally. Okay, so it's a way to figure out how to reduce big numbers. I wouldn't use prime factorization on ones that you already know, that are small numbers and you can find them really easy. So an example of that is if you have 150 over 160, all of us know right away that both of these are divisible by 10. So as long as we do the same to the top as we do to the bottom, this would reduce down to 15/16. So that's one. I don't really need to do the prime factorization on that because I can see it very easily. But when you can't see, if you have 55 and 165 and you can't see what really goes into those, go ahead and use the prime factorization because it will help you and you'll be much quicker and you won't be trying to guess all sorts of numbers trying to get them to reduce down. So these are the things I really want to focus in this section, 3-2. It also focuses on a little bit in the book, and I'm going to show you that. If we are trying to compare fractions, and what you're really doing is just trying to get their denominators the same. So if I want to know, is 5/6 bigger, smaller, or equal to 7/8, okay? One of the ways we can do it is to make their denominators the same. So we could just multiply both numbers, this number by 6 or 8 over 8, this number by 6 over 6. So what we're actually doing, so we're going to multiply this by 8 over 8, which is really 1. It doesn't change the fraction. We're going to multiply this one by 6 over 6. And then we're going to have the same denominators on the bottom. And it's easiest just to use the numbers that are on the opposite one. Just use them to multiply. So this gives me 40, because 8 times 5 is 40, over 48, because 8 times 6 is 48. Here, if I do 7 times 6, it's 42 over 48. So this one here is larger, so we can say that 5/6 is, we wrote that backwards, that's larger. So 5/6 is less than 7/8. Or you can say 7/8 is greater than 5/6. So that's something else that it's going to have you do in the book so you can compare the fractions and know which one is larger. Okay, so that's what we're looking at for these 5-3-2, and you've also been given 3-1 today, so hopefully now you can do that.